So we're now going to look at chapter 18, number 58. Number 58, you have three charges. Q1, that's 25 microcoulombs. Q2, that's 11 microcoulombs. And Q3, which is 45 microcoulombs. And at the same time, they also tell you the distances between all these. 2 meters, 1.5 meters. And what they want you to find is the total electric force felt on Q2 by the other two charges. So in order to do this, we think of Q2. Q2 is going to have two forces acting on it. One from Q3, which is going to point to the left. The reason the Q3 charge is going to point to the left is because they're both positives. So because they're both positives, they want to repel. So Q2 is going to want to move to the left. There's also going to be a force caused by Q1. This force is going to point to the right for the same reasons. Q2 and Q1 are both positive, so Q2 is going to feel a force wanting to push it away from Q1. Now to find the total electric force, we simply find the net force by finding F1 and F3 and then adding them together. We find F3 by taking K, Q1, Q2, in this case the charge of particle 3 and the charge of particle 2, and dividing it by R squared. And when we do that, we get 8.99 times 45 microcoulombs times 11 microcoulombs divided by the distance between them, which is 1.5 meters squared, and then we end up with 1.98 newtons. Then we do the same thing for F1, this time using the charge of the 25 microcoulombs and the charge of the other object. And then when we actually plug in our values, we end up with F equals 8.99 times 10 to the 9th times 25 microcoulombs times 11 microcoulombs divided by the distance between them, which is 1.5 squared, and we get F is equal to 1.098. Then to find the total electric force, we simply take the 1.098, which is positive, minus the 1.98 newtons because it's pointing to the left. And then our total net force is 0.882 newtons, or we can say 8.82 times 10 to the negative 1 newtons. And that would be pointing to the right. Then the question asks you what would happen if the 11 microcoulombs were negative without any further calculations. Without any further calculations, the only thing that would change is because it's negative, it's going to be attracted to the 2. So all our numbers are just going to be the opposite of it. So instead of getting 8.82 times 10 to the negative 1 newtons to the right, our answer would have been negative, which will, well, not negative, but 8.82 times 10 negative newtons to the left.